Welcome to the TPC desktop video series on using Traverse PC for the public land survey system. I'm going to bring over a plat that was done in 2008, and I'm going to zoom in on section 1 here just a little bit. And let's go ahead and use Traverse PC to start here at the north 16th on the east line. We're going to work our way around counterclockwise, putting in the dependent resurvey information on this survey, and then we're going to check our closure. Let's go ahead and get started on that. From the task manager, I'm going to tell Traverse PC I want to do a new survey, and let's go ahead and give this a file name. I'm going to go into version 12 test and PLSS, and we're just going to call this section 1 video. I need to pick my coordinate reference system. I'm going to use NED 83 for the continental US. This is going to be in the Oregon South zone. Let's go ahead and choose Oregon South on the list here. We want to make sure that we're using the GRS 80. So let's go ahead and close that out. The rest of this looks good. And then we want to set our information for this particular survey. And we're going to set the elevation to 4,300 feet. And this is important. I'm going to pull down the distance preference and choose geodetic distance at project elevation. And you notice the PLSS after it is our indication that that's the setting we want for the public land survey system computations. And we also want true bearings. So that tells us, or gets us all set up to work on the PLSS. So we're all set. Traverse PC gives me a few hints on how to get started. I'm going to come over to our traverses here. I'm going to double click any blank line, and we're going to call this section 1. Dependent resurvey. I've got a format called PLSS that lists the true bearings and ground distance for me, along with latitude and longitude. And then I've got settings for property lines that are going to draw this for me. We'll go ahead and set that tag and choose OK. So here's my traverse view where I can start entering data. And I notice on the plat that I have a starting latitude and longitude. And I'm going to go ahead and use the GCDB point labeling here. So this north 16th on the east line is going to be 700, 660 for a point label. And I can enter that right on the keypad, which is nice. Let's go ahead and enter our latitude, which is 43.2100110. So I just enter one decimal place after the degrees. It's positive, so it's north. When I enter a longitude, I can either do a minus or a W. I'm going to do a minus 120.2410.266. Traverse PC goes ahead and puts the W in there for me and displays my convergence, which I'm going to check as 3 minutes 59 seconds, so I'm good. Now, I could also, if I wanted to, enter this description and call this the north 16th on the east line. The nice thing about using the GCD point numbers is that I really don't have to put those descriptions in then. Did you notice that it dropped down to the true bearing? And what I actually want Traverse PC to do is to go through the point label each time. So I'm going to go to the edit sequence and put a P in there for point label. And that tells Traverse PC that each time I enter, press the enter key, I want it to come back over here so I can enter the next GCDB point label. So let's bring our diagram over once again. And we can see that I've actually started here now at the north 16th on the east line. And we're going to then head over to the center north 16th here, and then on up to the north quarter corner. Just wanted you to see that once again. And I've actually got this on another monitor so I can pull those bearings and distances right off. Okay, so let's head west on that 16th line in Traverse PC. My first bearing is northwest 89, 27, 49, so I do a 4, 8, 9, 27, 49, enter, and put in my distance. Now Traverse PC drops me down to the next point. If we want to see what we're doing while we're entering the data, let's bring up our drawing view, and I'm just going to call this a working drawing. And I'm going to put this on a template just called empty, because I don't want to have a lot of other stuff on there. And let's go ahead and do a zoom extents. So Traverse PC can draw that on for me. And there's also an auto extents, so that as I enter data, Traverse PC will continue to update that drawing so I can see what I'm working on as I go. If I want to create more room on the desktop, I can unpin those managers, and now I've got a lot of desktop space here to work with, which is kind of nice. Okay, so let's go up to the north quarter corner. That'd be 640, 700 for our GCDB point label. Let's put in our bearing. This is the northwest, so it's a 400, 0013. Notice how it takes 3 digits to get the quadrant and the bearing. 1977.201. Again, Traverse PC is computing the position for me. It's computing the latitude and longitude because we're doing a geodetic computation, and displaying the convergence then at that foresight point of 640, 700. Okay, let's drop down to our 600, 700, which is the northwest section corner. Our bearing over to that is northwest 89, so 489, 5509. My distance is 2655.579. Okay, so pretty simple just to be entering the data in like this. Now let's drop down. Next point will be 600, 660. Let's get that 16th corner in there. My bearing is going to be southwest, so that's a 300, 0927, and a distance of 1957. Remember, we're closing out on a standard parallel here, so we've got excess in the northernmost tier. My next point then is my 600, 640. Here I've already entered a bearing, and I'm extending that bearing along this west line as I head south. So I'm just going to press the space bar and then enter. And that recalls the bearing from up above, the previous bearing. I can do the same thing with distances or descriptions or whatever I might happen to have here. Okay, this is a regular 40, so 28301. We're pretty close to it. Well, let me go back and enter that. Now, if I entered something wrong, pretty simple for me just to go back and put the right number in. Press enter. Traverse PC recomputes for me. We're going to drop all the way down now to the southwest corner. That'll be 600. 600. We're extending that bearing again, so space, enter, works just fine for that. My distance is 2656. 599. Okay. Now we're going to move over to the south quarter corner, so that'd be 640, 600. The bearing is southeast now, so that'll be a 2. 0804. Distance is 2673. I know it's pretty boring to watch someone just enter data like this. Okay, let's come over next then and do our an E16th on the south line, so that'd be a 660, 600. Again, we can extend that southeasterly line, distance of 1336.650. And now we're going to go over to our southeast corner. Again, extend that line just by pressing the space bar. Let's come up to our east quarter corner. And this is a northwest bearing, so it's a 400. And then we're going to close out, and I'm not sure the proper way to do this. I'm going to create a unique point called 700, and we're going to enter then the closing information of that. So it's the northwest 400.0143, and our distance of 1339.13. Okay, so I can see in the drawing now I've closed out the perimeter of that section. In the traverse view, I want to go right to the closure view. And the closure view is going to tell me how I did. And I noticed right off the bat that I closed pretty well, so I probably entered the data correctly. And as we look at this, if I didn't get the right closure, I'm just simply going to go back and re-enter it. Now, I'm going to bring this plat over just for a moment again and zoom back out. And I've got a table down here with the areas in it. And if I add these areas up for section 1, I get 603¼ acres, so 603.25. Let's take a look now at Traverse PC's closure view and the parts of it here. And I'm going to see that this is the closure view for section 1. It's a dependent resurvey. Here's my Traverse summary. Okay, this gives me my horizontal distance around the perimeter and the slope distance around the perimeter, and then I get my area. So here's my 603.25 acres, okay, just what I had published on the plat there. And this is actually distance at the project elevation of 4,300 feet. Because remember, that's what the PLSS specifies, is that we're going to do geodetic or true bearings at a project elevation. And so the acreage, the distances that are displayed here, all of this is at the project elevation. Now, a lot of the computations are done on a state plane grid. That's how when we set up our coordinate reference system, that's why we got the convergences that we did. But Traverse PC understands the relationship there and gives us the proper information. Now let's look at our error summary and see how we did. So that's the next section down in brackets here. We've got our relative error and our linear error. We've got the direction of the error, and then, of course, the latitude and departure. Now, this is relative error of latitude and relative error of departure. Remember, if I remember right, we have to have a 1 in 4,000 closure for latitudes and departures independently. So we've added up all the latitudes, all the departures, taken their errors respectively, and display the relative errors of each. And then, of course, we've got our closing error here, both in northings, eastings, elevations. And we can come down then and see that we haven't done any adjustments, and in fact we won't do any adjustments on this one because it closed out just fine. I'm going to close out this closure view. I'm going to bring back up our Traverses Manager and just show you that we formatted the Traverse view, or Traverse Manager here, to include the acres as we enter these different sections and as we create the lots in them. So in addition to having the acres in the closure view, I can also display them here in the Traverses Manager. And in fact, if I want, I can come up and tell Traverse PC that I want to format this to also include that linear error. So let's find out which one that is. That's an E. Let's turn on the E also. And without going to the closure view then, for each section I'm going to enter and each of the lots I'm going to enter, I can get my area and linear error. Let's come back to the Traverse view just for a moment, and I want you to see again that what we've actually entered for this section are true bearings and geodetic distances per the dependent resurvey. Traverse PC computed the latitude and longitude for us, so we have those geodetic positions as we go around, and gives us the convergence factors and also a scale factor if we want, that relate these geodetic positions to a plane coordinate system underneath